Liraz Siri?
Yes.
Cool. Alright. So we need to put your presentation on it. Did you actually send it or not yet?
I did send it, but if possible, it would be better to use. Technical hiccup finding a presentation on the official computer.
I'm only 1 minute late, so that's fine.
Okay. Yeah. No, I don't have an adapter, so
We'll have to do it.
yeah.
Your impression.
Alright. Okay. Just gonna have to. Oh. Is this Oh, you mean?
HDMI.
Oh, okay. Let's. Yes, we will try. We will try it right now. Hopefully it works. And
It's a USB thing.
yeah, let's do this.
I think you install some software.
That'll be the clip.
Okay.
Forward and back.
And
So-
this is for the click, so you need to plug it also there.
Wait, so how does my screen get this?
You're gonna have to plug this one in as well.
What, this one in?
USB.
Okay.
And now
This needs some software to be installed.
it doesn't have the software to be
No?
installed.
Oh,
I think it might.
Oh,
actually.
okay.
it needs software? Or it's
I
not a
think-
screen?
It's USB, so I don't know.
Okay, that's not gonna work. Yeah, no, it's like, I'm not gonna install, I'm not gonna have time to install software. Just like, just get presentation on the computer. It can be the old version too, that I sent. It's not a
The
big
thing
deal.
is, it's not downloaded on the computer yet.
It's not online yet?
It's not on the Google Drive on this computer.
Could you,
Let's have a look. Have a look. Is it in there somewhere?
Oh no, it is not. It's unfortunate. So there is one officially bus computer that can transmit the screen, and for some reason they did not get my presentation on this computer. So now we're stuck. But what I could do, because we don't have that much time, maybe we could just start. And you guys won't be able to see it, which kind of sucks, but at least I'll be able to explain parts of the system and what we've done. This is the best we can do.
So that's the mic.
Yeah. Hello? Yes. Yeah. I will be able to send anyone that wants the presentation. Actually, I can send it to everyone, like right now. I could just post it on Twitter, and then you guys can open it on your devices. Like, let's do something more decentralized. The centralized computer is not working for us. Okay. So I'm posting this right now on Twitter, and wait.
D'accord. On a le lien Google Drive si vous voulez. Oui, c'est ça. Le fichier pas dessus.
Yeah. Well, that's the thing, but we don't have the Google Drive yet because it's not on it. So there's nothing we can do.
Okay, well. Maybe you can do a Google Meet with that laptop and share your screen. Ryan?
Well, if you know how to do it, you're welcome. I don't.
I can if you want. Do you want?
Yeah, sure, man. Come in. That'll be better. I think everybody's waiting for that. So.
No, I'm just going to post this right now.
I'm the AV guy for Tenderly. Hi, everyone. Yeah, just a second. I'm going to start a meeting on my phone. Liraz, I'm going to send it to you on Telegram, okay? Wait, I'm going to send it to you on Telegram. Let's see. I'm going to use our group chat there. And then I'm going to type it out here. Just give me a sec. Oh, this is a French keyboard. Okay, can you please type this in?
Which one? Meet?
It's the gift that keeps on giving. So I posted it on my Twitter. My Twitter is at Liraz, Liraz. It's my first name. Siri, like Apple Siri, Siri. And I mean, if you have internet access right here, like it should be, you can just open. Maybe we can get this. Like if.
But if you want to use your laptop, or you just use it on Twitter.
I mean, we actually, yeah. Let's just. Could you open my Twitter account and we could just get the link from there. Yeah, yeah. No, I mean then. Just yeah. Let me.
It's still French keyboard.
I will. Oh. Where is Z? Z. Okay. All right. All right. Okay. So, and then what is the presentation button on this thing? How do I? Okay. Wow. This is it. Okay. Yeah. All right. This clicks.
And this, let's have a go.
And can we? Okay. Oh wow. Okay, we got this.
Does it work when you move pages?
It does not?
It does.
Oh, it does. Okay. All right. So if we have time, if you don't kick me out, I will try to figure out a way to do an interactive demo. So with a computer out here, because I was expecting to be able to use my computer. But the gasless token mixing demo is live on mainnet. So anyone that has DAI can use that right now. And we're going to be talking a little bit about that, and also more generally how GSN2 enables gas as a service to unmodified contracts. Right, and we're developing this as an open source project called OpenGSN. Okay, so what's new in GSN2? Well, we realized that to make GSN exciting, it has to have concrete use cases, and gas abstraction and gasless interaction with contracts. That's, we realized that it's not something that like new users would be comfortable with. They don't have a concept of gas when they're interacting with regular servers. So we want to make that go away. But for this ecosystem, most people have a handle on that, and we want to find it like very compelling use case that we could show off as reasons for explaining why we need to be able to support gasless interaction with any contracts. So the GSN proposed a way of modifying contracts to be capable of receiving meta transactions on their behalf. And this means that instead of requiring an account with ETH on it, and then you have to put that transaction on chain, what you do is instead you could have a system of relays. I hope to explain a little bit how that works. And then that relay can submit the transaction on its behalf. And in the meta transaction, there is sort of a proof that the relay is going to be compensated from another contract. So you don't have to worry, and they get a transaction fee. And this has been around for a while. What GSN accomplished is a decentralized network of relays. But the limitation with GSN1 is that it only supported contracts that were GSN aware. And this has not been established as de facto meta transaction standard yet. So it's really hard. It's a chicken and egg problem. And we realized if we wanted to accelerate adoption for meta transactions, we would have to figure a way to both natively support modified contracts that have been modified to be GSN aware, and maybe that's the ultimate integration, but also figure out how to support unmodified contracts if you want meta transactions today. So what's interesting about this is when we do this, it creates a new type of business model where you can have a contract that is providing gas as a service, and this would be something that could be useful for wallets, for example. And then the wallet could make it very easy for their users to interact without ETH with dApps on the Ethereum blockchain. And the wallet is paying for the gas fees of the users as a service. So that wouldn't require the usual KYC process. If a user wants to interact right now, they have to buy ETH, and buying ETH is something that usually requires a KYC process. But if the wallet is just paying for your gas as a service, that does not require KYC. It's easier. It's also possible to implement other types of business models. So for example, the hosting model that we have with servers is, if you don't want to host your own server, you pay someone else to do that. And users, they don't have to think about, oh, I'm going to pay for my interaction with a server. And you could have something like this for dApps, where dApps sign up to a gas as a service provider. And at that point, the onboarding process for their users, maybe all the interaction is abstracted away, and it kind of looks a lot more like a Web 2 app. So we will not be able to do this on my computer, but this is working live on mainnet. There is no link, which is unfortunate, but it's GSN minus tornado. Actually, I may post on that on Twitter yet later. It's GSN minus tornado .openeth .dev. That's where the demo is living right now, and it works on both Kovan and mainnet. And the way I set up the demo is you have an account that only receives DAI. The use case is, let's say I want to perform a contract, and I don't want to give away my main account, because then wherever I'm working for, they can see all the other contracts I'm getting, they can see how much money I have, right? Like I'm giving up all my financial privacy, and that's not really desirable. So the use case is I could create a new empty account that it's never been used before, and you can give that as the recipient address. This is kind of how like Bitcoin HD wallets work. They generate these one-time addresses. And that works great for ETH if you use a mixer, but it does not work for tokens. And if I want to get paid in a stablecoin, DAI, USDC, because I don't want to speculate on the value of ETH, then I have the problem of, okay, I received these tokens, how do I transfer them to my main account without compromising my privacy again? If I send ETH from my main account to this new account, then of course like the accounts are linked. And being able to support gasless token mixing solve that. Now you can just, and this is the demo, is you go to this version of Tornado that we've hacked to use the GSN, and you select an account that does not have ETH, and you send deposit, you pay 1 DAI for the deposit. So I mean the minimum deposit in Tornado is 100 DAI. We think it's possible to make some improvements. And you get back a receipt, a little note that you have to save somewhere, and then from a different account, maybe your main account, it can also be another account that does not have any ETH. Then maybe you wait a while because you want to benefit from the anonymity set and let other people make more deposits, right? But at some point, you take the receipt, which it's possible to generate a zero-knowledge proof from, and then you ask to withdraw to any other address. And yeah, that's working. Afterwards, if anyone wants to try it, or I will stick around and show this on my computer. So how does it? So this is sort of how it works in principle, very high level. So there's a dirty source address, which what I mean by dirty is there is a person associated with that. There's my identity associated with that, right? And I wanna clean that linkage away. But because I don't have any ETH, I can't create an Ethereum transaction, right? So what we do instead is we are signing a meta transaction. And that meta transaction, like we're submitting it to a relay on the GSN2. A relay is looked up by the client code. It's something that can live in does live in your browser. And then what that happens is that the relay, it checks that GSN2 Mixer app, it has sort of a gas tank, right? It's registered in the GSN as offering to accept meta transactions on behalf of Tornado Cash users, or users of this demo. But it first checks that the user has sort of signed a pre-authorization to charge the gas for that transaction.
In the demo, it's just one die. They make sure that part of that transaction, once it's submitted, will pay for the GSN2 mixer gas fees. And then once it's submitted, the GSN2 mixer actually authorizes one of the relays to pay for it. The relays pays for the transaction in ETH for the gas. And at that point, it's just like a regular Ethereum transaction, right? And behind the scenes, the relay gets their ETH back from the GSN2 mixer wrapper. And again, this is trustless. You don't have to, the relays don't know, they don't have to trust or know about the GSN2 mixer. This is happening through the relay. The relay hub brings all the participants together. And so the GSN2 mixer doesn't run out of ETH itself, then it swaps the DAI for ETH. And we can do that dynamically in the demo. We're doing that statically just to simplify things and charging one DAI, but probably makes sense to do this in a more dynamic way in the future. So this is what happens in the background. So yeah, the client, it's signing a meta transaction that gets turned into a relay call, right? A relay is looked up. We've sort of assumed that we did that step already. And the relay call is a call to essentially like it asks the GSN2 wrapper like, are you willing to accept this call, right? And this is a view function, so it doesn't cost gas. And what GSN2 mixer does is it actually goes to the DAI. The DAI contracts, right? Because you have on your address, you have some DAI to your credit, and what we do is DAI also natively supports meta transactions, which is how we don't have to modify Tornado Cash, and we can still use external accounts. So what we do is we sign a transaction to authorize to give you an allowance to pay back the GSN2 mixer. That's the first thing you sign in the demo. And after we say, okay, we see that DAI says yes, the allowance has been signed, then we do a pre-relayed call, which eventually results in a transfer from the client to the mixer itself. And then the mixer, it serves as a proxy. Like the GSN2 mixer is a proxy to Tornado Cash. So in one atomic transactions, it will send the funds to Tornado, and then it settles for itself the DAI by using Uniswap and refunds it. So, and then when you withdraw, so But this flow enabled that wasn't possible before. You could only use Tornado Cash if you already had ETH, right? Now the advantage of using the GSN for withdrawal is slightly different because Tornado Cash did integrate their own centralized relay, but they also integrated a feature which allows you to specify, okay, I want to use like another relay or want to use a different wallet. And we take advantage of this. To wrap around Tornado Cash. So what happens with a clean target address, it's an address that can have nothing. It can have no ETH, it can have no DAI. It's completely clean and empty. And it signs a withdrawal request through GSN. Like it submits the transaction to GSN2, and then this is verified by the GSN2 mixer, which is proxying the request to Tornado Cash and asking like, okay, is this, essentially you have a receipt. That's one of the things, what you get back when you do a deposit, right? And you can submit this receipt back, say, okay, now give me 100 DAI. And it's a view function. So the view function is called, actually, there's another flow, but I didn't know if we would have time to do another flow. I can do that after. And bottom line is the funds are withdrawn from Tornado Cash using the GSN's decentralized relays, which means that anyone can this happens transparently, but if you use Tornado Cache without this, then there's one specific relay that you're using, like the DApp selects that for you, and there's a fee involved, and it's not a competitive relay market like the GSN. And also, if someone wants to prevent you from using the DApp, if they take down the relay, they attack it, do a denial of service attack, then nobody can use the DApp. And with the GSN, like anyone can set up their own relays, and like the client code automatically selects relays. So, all right. So let's talk a little bit about what's happening under the hood for GSN2. But first, a primer. I'm not sure everyone is familiar, so just explain like what the decentralized network of meta-transaction relay means in principle. Meta-transactions are a format of signing a message, and then if you give it to a relay, the relay can sort of open the envelope and submit that as a transaction. But there's the problem of why would the relay do that? How do you incentivize the relay? And what the GSN does is it uses an on-chain contract called the Relay Hub, and essentially to create this registry of relays that anyone can set up. So an Ethless client, what happens is they are looking up relays on Relay Hub, selecting a few randomly that have been giving service recently, and they sign the transaction and they send it to the first relay, right? They get back an immediate response. The relay, of course, it checks with the Relay Hub that there is a destination contract that is willing to pay for the transaction, because the relay is getting transaction fees, and so somebody has to pay for that, right? And then, yes, if the collect call, that's another way of thinking of it, is allowed, you receive transaction fees. And the way you prevent relays from censoring you or for doing blocking you for too long is after you get the request back, it's a signed commitment on behalf of the relay to submit the transaction on chain in a timely manner. If it does not do that, then you can the other relays can penalize it. So you can submit. All relays have a stake. They need to stake into the system in order to participate. This binds them to perform like some level of service. And if they don't do it, then their signed commitment is something that you can use to penalize the misfunctioning relay. So in GSN1, we got all this to work with GSN aware contracts. And that was nice, but there is a catch-22 of until you have a well-established standard, as a DApp developer, you're not sure what to use. Would you make modifications to your contract? Also, this doesn't work with contracts already live on mainnet. And if there are multiple competing standards or competing approaches, as a DApp developer, you're just incentivized to wait and see what happens. But then this results in a deadlock where no standard can become dominant enough to get that consensus, and then DApp developers continue waiting. So for the GSN2, we still make it possible, of course, for contracts to interact, to do a direct integration with the GSN, and then this allows GSN-aware contracts can interact with external accounts. So if you look at a block explorer, you would see the tokens or the actually to an external account, to an external key, and still work. What we changed in the GSN is that we separate the logic of like whether you're a recipient from who pays for it. So you could be a recipient. You can add a very small modification to your DApp that allows you to be a recipient of meta transactions without any of the accounting logic, without having to decide okay, how do I pay for the transaction? And then there's a separate system of paymaster contracts. They could be run by wallets or gas as a service providers of all kinds, and they can fund any contract that is that is GSN aware directly, even from external accounts. But to take it a step further, this is what we're really excited about, is with the same architecture, we can support unmodified contracts, but we deploy through the GSN2 a gasless account. So at the minimum, this is a proxy. It is a proxy. It does require some changes to client code because the owner, let's say there's DAI in this gasless account, the DAI is registered to the gasless account. And then this gasless account maybe is just verifying the signature from an external account, right? But if you're using a regular, like a client that doesn't know about any of this, then it would look on chain and see like you don't have any DAI, right? So the client would need to know about the gasless account. And we're exploring like different approaches for gasless accounts. We've created one prototype that's optimized to work with the GSN and has a flexible security policy. But the most simple version of this is just a proxy contract that verifies that an externally owned account has signed the meta transaction. That's it. And this works now with anything on the Ethereum blockchain. So yeah, I mean, if we want people to actually use dApps, dApps can control their own tokens, and some of these tokens can be swapped for ETH on Uniswap. And maybe the dApp has an incentive to give you tokens to get you started. But because you need to get ETH from somewhere, then that complicates things. And we think we can remove one of the roadblocks to mass adoption by getting rid of gas as something that the user has to be aware of. So this is sort of an example of a GSN2 token paymaster. And this is something that we could implement once. We have implemented it for DAI as an example. And the same architecture that I was speaking about before, which is here, like the last one, just expanding a little bit about it. And the way the GSN2 token paymaster works, and this is something that you can also take a look at the code if you're interested. But essentially, it checks that, well, first it deploys gasless accounts on behalf of users that are like authorized to get service, right? The deployment of the first gasless account could be paid for by itself, which is kind of weird, because you see an externally owned account suddenly transform into something else, and we use create to do that. It's not really intuitive, but essentially we can calculate what the address of this account is going to be, and then you can send tokens here, and I mean the user doesn't even have to be aware like they have an external account somewhere. That you can abstract that away, but what happens is you send tokens to an address that looks like an external account, and then later you sign a meta transaction authorizing the token paymaster to pay for its gas from those tokens. And the first thing it does, it actually deploys the contract. So you have like a slightly unintuitive situation where a contract is paying for the deployment of itself. And we can do that safely without trust because once we pass through the GSN2, a signed meta transaction that authorizes the token paymaster, which isn't just a contract on chain that you have the source code for, so you don't really need to trust it either. Once you have the signature, you know that once you submit the transaction to deploy the gasless account, you are going to be paid back for it. Another way of doing it is just to have somebody that sponsors the creation of gasless accounts for users. Maybe that could be a dApp that wants to onboard them. So we actually have a nice demo, and we're making this a lot easier now in GSN2. We got it to work kind of in GSN1, but it was very, very complicated. And with GSN2, by separating paymasters from the recipients, we've made that dramatically simpler, and you can have as many paymasters as you want, different models. And the bottom line is now you can interact gaslessly with any unmodified contract on the Ethereum blockchain that as long as you have tokens that can be swapped for ETH on Uniswap, right? So GSN1 has been live since August on mainnet, and it wouldn't have happened without all the help we received from the community. And yes, if we have time for questions, then I'm also sticking around if anyone wants to have a conversation about it. Yeah. Well, yeah. Yeah? Oh, great. Oh. What, this one? Oh, okay. Yeah. Yes.
Yeah. So actually, last year, my company released with. Let me give you that. We modified the Gnosis multisig contract to make it GSN enabled.
All right.
And we just went through audit. So yeah, modify contract. So just to understand, it's still gonna work like as it is now with relays, and or.
So we're changing. We're not changing the fact that the relays are registered into the relay hub, but what we realized talking with dApps is they want to set up their own relays, and we want to encourage them to set up their own relays, right? So with GSN2, the default is for a dApp to set up its own relays, but they're not centralized. If they get attacked, if they fall down, traffic is routed through the relays of other dApps that are still up.
Because
okay.
Right now we use Portis relay.
Yes.
And are they gonna still? They're still gonna. Have
yeah. I mean, there's no reason for.
Okay. So it's backward compatible.
Well, GSN1 is not backwards compatible. It's like, with GSN2, it's a completely new system. But from the relays perspective, not a lot. There have been modifications, but it's a very simple upgrade. But GSN2 is a new system. It wouldn't be possible for us. Like, we made significant changes to the API of the relay hub. We've separated the architecture, actually breaking apart the contract into multiple pieces that are easier to audit. So you'll be able to, the most critical piece of the system from a security standpoint is a forwarder contract. And that is something that if it fails, we're in trouble. But there's like most of the complexity of the system is actually the relay hub registry, relay registry, right? And we want to make sure that we have compartmentalization. Different parts can fail. So the bottom line is it's the same general approach, but re-engineered to be like more robust. Slightly more robust. And also, dApps don't have to trust that there will be some other relay out there that are servicing. It's very, very easy. We're making that like, a 5-minute relay deployment process for the dApp. And you still get the benefit of a fallback to the relays of other dApps if your relay falls down, right? The relay registry?
I mean, when I want to broadcast a transaction,
yes,
it is happening off-chain because I'm just signing some message and sending it to someone. So there is some REST API that is automatically sending your signed message to the relay, or how does it work?
Well, so the way it works is that we have a Web3 provider, right? And we have a trick for taking the existing Web3 providers and hooking into them, so the dApp doesn't need to make a lot of modifications. After you do that, what happens behind the scenes is that we insert a process where the client code is now, it's executing a view function on-chain in the relay hub and saying like, what relays have been active recently, right? And then like in the last week, because you don't want to reach out to a dead relay, you take the signed meta transaction and you submit it to one of them. They are supposed to give you an immediate response back, committing themselves to transmitting the transaction and getting the transaction fee. So this is not like where you submit it to a node and then through a peer-to-peer protocol. This is not like this is a client-driven approach. And you can do that safely because the relay is committing itself by having a stake on Relay Hub And at that point, like if it misbehaves, you can penalize it.
So every time that you have a new relay or someone don't want to be a relay anymore, you should update this contract. I mean, you said that you have a.
Oh no! It's the registry is on chain, yeah. So like when you essentially there's client code that just asks a contract on the Ethereum blockchain which relays are active right now, which meta transaction relays will accept the transaction, and what fee, right?
Yeah, I get it, but how do you know which are active right now?
Yeah, well, every time that a relay accepts a transaction, it emits an event. And you can do a filter on the events, and
so you're checking the recent activity of these relays, and if they had done some transaction recently, then you consider that they are active.
Exactly. So there's a mechanism for choosing relays that are most likely to respond, and you can play with things like what is the size of their stake, right? And what is the fee that they want, because it's a dynamic fee market. Like any relay can say, I'm willing to service. That's another slight modification that we made. That now relays can say, I want like a fixed amount for each transactions, or I want it to be a percentage. Like we're making it a little bit more flexible.
Was some rating system probably?
Yeah, and you can have rating systems. It doesn't have to be on chain. I mean, we want to achieve trustlessness, but we don't want to have to create a new consensus protocol, because as you're inventing a new blockchain.
Yeah, basically it's a hard task to solve. Yeah.
Yeah. So.
Thanks. Last question.
Just does it work both with ETH? Does it work only with DAI or also with ETH deposited, the mixer?
The mixer work only?
Yeah, the heck mixer.
Oh no, it works. It still works with ETH. Yeah, it works with ETH. If you don't feel comfortable playing with your real DAI, there's a version on Coven. But you can, the GSN like minus tornado .openeth.dev. There's also the source code for the demo on our GitHub, so you can take a look at that. But if you want to play with it without taking risk, then you have to get some Coven DAI, and you have to add like to your MetaMask the DAI contract on Coven. Right? It's a little bit inconvenient to do that, but yeah. Any other questions? Okay. I'm sticking around, so yeah. Thank you, everyone.
So I'm sure I understand, because my contract is modified, like for that's accepting relay call. It's still going to be working.
Yeah.
I mean, like.
Wait. We're not taking down the GSN1.
Oh, okay. That's what I mean. It's a new thing. It's a new thing. Okay.
It's going to be a new relay.
People are still going to relay on the first.
I expect so.
For some time.
If it works, like you don't have to.
Yeah.
If it works, don't break it.
Yeah.
I mean, we couldn't take it down if you wanted to.
Yeah, sure. Yeah.
I mean, it's not ownable by anyone. You know, it's not upgradable.
It's good now that you don't have to modify contracts.
No. Yeah. I mean, that would also show a security weapon. Like if we can modify, if we can take down contract and like break everyone's code, that would be. I consider that
it's still gonna be working.
Decentralized. Yeah, you don't have to worry about us breaking your code. Hi.
Unfortunately, we missed